It's time to move into everybody's favorite topic, and that is TCP/IP subnetting. When Cisco split the CCNA into two separate certifications, the CCENT and the CCNA, they also split the subnetting concepts. In the CCENT, they introduced subnetting and they even got pretty complex with it, but they didn't go all the way, meaning there was one piece of subnetting that Cisco left out of the CCENT testing objectives, and that is known as variable length subnet masking, or VLSM. This is going to be where we talk about VLSM in the icnd part 2. But I want to make sure that everybody is familiar with the icnd part 1 form of subnetting. It's a method of subnetting that I've been using for quite some time. It's pretty simple, but I also realize if you haven't gone through icnd part 1, you're going to be completely confused when you see the style of subnetting that I used here. So what I have right here is my first objective to talk about is to remind y'all that we have as an appendix to this series all the subnetting videos that I created for icnd part 1. So if you have not seen icnd part 1, or it's been a while and you need to review before we get into the advanced subnetting, feel free to look through those appendix videos and check those out. Also with those videos is tons of practice for you, so you can actually practice through some questions on your own and then review yourselves and the answers. Those practice questions and answers are going to be available on nuggetlab.com it'll probably be under the icnd part 1 video series. You can download those, no login required, no cost to you at all to work through and practice them. So what we're going to do here is the second bullet, working through a VLSM scenario. VLSM stands for Variable Length Subnet Mask. It's a technical term, but really a simple definition. All it means is that you can change your subnet mask whenever and wherever you want on the network. Now remember what subnetting is. Subnetting is taking one network and breaking it into mini networks. For example, we have 192.168.10/24 here, and I could break that into mini networks to address this network that you see in the diagram. But notice the statement. It says subnet 192.168.10 to address this network using the most efficient addressing possible. Whenever you see most efficient addressing possible, that means we're going after variable length subnet masking, which means you're going to use custom subnet masks for every segment of the network. Now, VLSM, in my opinion, is no more difficult, even though it's the most difficult of the CCNA series. I don't really think it's that much more difficult than any other subnetting problem that we've seen thus far, if you've looked through the appendix videos. But what I will say is it will take longer because it's multiple subnet problems in one. So let's work through this scenario one network at a time. So what I'm going to do is squish that network diagram up in the corner so we have some working space here. And look at the scenario one more time. We need to subnet 192.168.10 to address the network using the most efficient addressing possible. Now, whenever you see that, think VLSM, and then think the whole key behind VLSM is to start with the largest subnet. Now, looking at that diagram, what is the largest subnet? That one. 60 users right there. So we need to start with that one. Now, this is using the methods that I was talking about in the videos in the appendices. So again, if you haven't seen those videos, now's the time to check them out. So we've got 60 users. I'm going to take my 60 users and convert that to binary. Put up our binary chart, 128, 64, 32, 16, 8, 4, 2, 1. 60 is a 1 in the 32, 1 in 16, that's 48. Add another 8, that would be 50. Oh, I shouldn't have done this in my head. 48 plus 8 is 56. So add a 4 and we've got our 60. So there's 60 in binary. 0, 0, 1, 1, 1, 1, 0, 0. Now, you might remember that we are not after the exact binary number. We're mainly concerned with how many bits it took to get the number 60. The number of bits is 6. So we can't get the number 60 with any less than 6 bits. So move on to step 2. Step 2 is to write the original subnet mask in all binary. So a /24 is 24 ones, so a whole bunch of ones. That's Imagine that being 24 of them. And then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now we've got 60 that we converted to binary. Are we after creating more networks here or saving the hosts? Well, looking at 60, I'm after the users. I need to save some hosts. So I take right to the left, 1, 2, 3, 4, 5, 6. The other two can become ones. I've saved my 6 zeros. So with that in place, my new subnet mask for the 60 user network will be /26 or 255.255.255, and this in decimal over here is .192. The lowest network bit is my increment. That's that guy. It is a 64. So I come down to my third step, and I can find my network ranges. So I go 192.168.1.0. That's where I began. And then I'll just go to 1.64 and actually stop right there. How many networks of 60 users do I need? Looking at this diagram, there's just one. So I can fill in the end range. That'd be 192.168.1.0 through 63. And there is my network range. What I'll do is on my network diagram, I'll notate that. As a matter of fact, let me type it so it's a little neater. Right here will be 192.168. I'll change that font in just a moment. Dot 1.0 through 63 slash, and I'll put my subnet mask, 26. Let me just increase that font size a little bit. There we go. I'll drag that right here. Good. So we've got that, which is now my first VLSM subnet. With that in place, the whole key to VLSM is now do it all over again. So I'm going to take what I've done. Oops. the one subnet I have there. Let me select the right field there. There we go. Erase it and start all over. Now you can see I've got one subnet solved. Now let's move to the next biggest. You see VLSM, you start with the biggest subnet and you work your way down. So I'm moving on to the next biggest, which is 20 users. So we'll take 20, convert that to binary. Oh, should have saved the binary chart. Save the chart. So 32, 16, 8, 4, 2, 1. And I'm going to say 20 in binary is 0, or oh, there's my first one right here. 1. Good grief. 1 and 1. The rest of these are zeros. So 20 in binary is 0, 0, 0, 1, 0, 1, 0, 0. It takes 5 bits to get the number 20. So step 2 is now to take my original subnet mask /24, write that in binary, 24 ones, and we're writing this as if I had never done any subnetting in the first place. There's my 8 zeros. Now I'm again after saving my host because I'm after 20 users, 5 host bits. So right to left, 1, 2, 3, 4, 5 remain zeros. The rest can become 1. My new subnet mask for that portion of my network is /26, or wait, no, /27, because there's 27 ones, or in decimal, it'd be 255.255.255, and that would be .224. Lowest network bit is my increment. Convert that back to decimal. That would be a 32. So, step 3 is to start off with what I was given, 192.168.1.0, just as if I had done nothing, and start adding 32. 1.32, 1.64. Now, wait just a second. Let's fill in some end ranges here. I'll go through 31 through 63. Now, can I use any of these? No, because they're already used right here. You see that one is 0 to 63. So that is unusable. That is unusable. I need to start off with where I left off, which is 64, and keep adding 32. So 96, 128. Now I only need 2 networks of 20 users each. So I can go in there and just stop after these 2 ranges. This will be through 95, and this will be through 127. You're seeing kind of how this works? So I picked up where I left off. 0 through 63 is used up right here. I have, let me grab my text tool. Going to copy this guy up here. So we'll notate 192.168.1.0, or this will be, let's change that, 64 through 95 slash 27. Good. And then I'll assign that second range over here to these 20 users. This will be 192.168.96 through 127 slash 27. Good. So now we've got both of those subnets completed up there, the two subnets of 20 users. And if you look, wham, there goes all our work again. It's gone because we've now addressed the 60 users and the two networks of 20 users, but there's still one more that's very easy to forget. You see the WAN links. How many users are on a point-to-point WAN link? 2. There will never be any more than 2 users on a point-to-point WAN link. That's the definition of point-to-point. So I'll start over again for my last network range, and that is 2 users. So 2 users. Let me put my binary chart back up there. One day I'll learn not to wipe it out. 8, 4, 2, 1. 2 users, that'd be 1, 0. So it takes 2 bits, or 0, 0, 0, 0, 0, 0, 1, 0. 2 bits to get the number 2. So I write my original subnet mask in all binary, /24, whole bunch of ones, 24 of them, dot 1, 2, 3, 4, 5, 6, 7, 8 zeros. Now I'm saving the host because I have 2 users, so those 2 remain zeros. The rest of them become ones, so I have 6 ones and 2 zeros left over. My subnet mask moves to a /30, or if I were writing in decimal, it'd be 255, 255, 255 dot 252. My increment, lowest network bit converted back to decimal, is 4. So now I go to my step 3, which is finding my network ranges. I can go 192.168.1.0.1.4.1.8. Now, hang on just a moment. Can I use any of these? 0 through 3, 4 through 7? No, because they're already used up right here. As a matter of fact, I could keep counting by 4, 12, 16, 20, and so on, and I'd go through all these ranges and all these, and they're all used up. Now, if you don't feel comfortable doing this, don't. But what I would say is it's a lot easier to just go dot, 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 and pick up where you left off. You notice right here, we ended at 127, so the next one would be dot 128, 132, 136, 140. If you keep counting by 4, you'll eventually get to 128. And you want to do that as efficiently as possible without filling the page with numbers. So I can now fill in my end range. That'd be 131, 135, 139. So let me grab my subnets I've been using right here, copy and paste them. I will assign this WAN link, 192.168.128 through 131/30. There we go. We'll use over here 132 through 135/30. And then finally, up here, 136 through 139/30. And that is addressing a complete network using VLSM. Now, if you look at this, it's pretty amazing because we've addressed this whole network and barely used over half our network range. If we didn't have VLSM, we couldn't do this. I was just thinking of that. This would be impossible because we'd have to, if we could only use one subnet mask, which is what VLSM is trying to prevent. If we could only use one subnet mask, we'd have to figure it for the biggest one. And if you go in increments of 64, you'd only get 4 networks. And you can see we would need more than 4 networks to complete that scenario. So VLSM is the only way that we could effectively address that network, and it is very efficient. Now, there's a couple notes I want to add on to this before we wrap things up. The first thing I'll mention is why we started with the largest subnet first. If you think about it, if we would have started with the smallest or some other subnet first, there would be waste. Notice it says use the most efficient addressing possible. Well, let's say we started with this WAN link subnet right here, 0 through 3, 4 through 7, 8 through, that would be through 11 if we were to continue that for our WAN links. So that would be if we started with the smallest, and that would kill this first group up to the IP address 192.168.1.12. Now let's say we move to the 60 user subnet after that. Well, our first range would be 0 through 63, but we couldn't use that because these were already used up. The WAN links already killed 0 through 11, which would overlap. So we would have to go with 64 through, what'd that be, 127 for this range right here, which you would have a waste. You would waste from 12 through 64 because you started with the smaller subnet rather than starting with the largest subnet. So that is why we start with the smallest one first. The second thing I want to mention, while I've got the diagram up, is VLSM like this looks beautiful on paper. But think real world with me here. If this subnet up here, our 20 user subnet, had a sudden hiring spree and brought on 50 new employees, well, that would blow up your whole IP addressing scheme because you would exceed your 20 user subnet, which only handles up to about 30 users, and you would have to readdress the whole network. So when you're doing this in the real world, always use room for growth. So don't subnet it so tight to where it looks perfect on paper, but only lasts a good year before you have to readdress the whole network anyway. And let's see, what else can I mention about this? VLSM is very commonly used right here on the WAN links. Most of the organizations that I've seen on all the point-to-point WAN links will use a /30, and on the LAN they'll use something easy like a /24. Even doing something that simple is using VLSM. That leads to the big point, which means if you use VLSM, you must have a classless routing protocol. And those include RIP version 2, OSPF, EIGRP, ISIS, and that's it that I can remember off the top of my head. The ones it does not include are the two classful protocols. Let's go that way. Classful is RIP version 1 and the old IGRP, which Cisco no longer manufactures. So classless routing protocols only will support that kind of environment. So that is variable length subnet masking. Not too bad, right? It's just multiple subnetting problems in one. Yes, it does take a little bit more time to do, but it's really, once you get past the idea of doing more than one subnetting problem, it's not too bad. Now, if you're preparing for the exam, you might be wondering, well, how would they ask a question like that on the test? Well, what I would say is think drag and drop. Think of having a picture of a network diagram and all these blanks where you can put subnets, and then they'll say subnet this for the best possible or most efficient way, and have all these options of subnets over on the left hand side that you can drag and drop to complete the network diagram. So when you're doing it that way, sometimes you may find it more efficient, depending on your skills, to reverse engineer all the subnets on the left hand side to find what would satisfy the requirements, or you may find it more efficient to do what I just did and do a complete VLSM problem. It's your choice. So we saw, first off, that there are more subnetting videos into the appendices. This is my recap here. If you do need more subnetting practice. And then we work through a complete VLSM scenario using one Class C subnet with multiple subnet masks to address the whole network. I hope this has been informative for you, and I'd like to thank you for viewing.